giving, I think, what is the second non-IBM Qiskit Advocate demo. And then feel free to take it away. The floor is yours.
Okay, I'm gonna share my screen. Turn off my camera. Share screen 1. Just let me know if you're seeing my screen. I have some slides.
Yep.
Hopefully it's in full screen now. Can you hear me?
It's in full screen.
Okay. I guess that's a yes. So hi everyone, my name is Omar Costa Hamido, and this is my Qiskit Advocate presentation. I titled my presentation Computer Music and QAC / QAD. And what is QAC or QAD? You are about to find out. Just a very short introduction for those of you who don't know me. I'm a performer composer. I play the saxophone and computer. I do multimedia work, music for electroacoustic music, music for live acoustic instruments plus live electronics, and interactive installation work. And I'm currently pursuing my PhD at UCI with support from FCT. The program that I'm pursuing is called ICIT, which stands for Integrated Composition, Improvisation, and Technology, which is basically a program for performer composers who use technology. So my experience with quantum computing hackathons is fairly limited to these 2 hackathons, the Qiskit Camp Europe and the Quantum Futures Hackathon at CERN. I'm not very good with online social media, but I'm very good with email and group work. And proof of that is the projects that came out of these 2 hackathons. The first one is the quantum synthesizer that won the community award. The quantum synthesizer was basically I built this Max MSP interface, and then we collaborated doing the Python backhand. It communicated with Max via OSC. They built they had some pre-built circuits, so I would just request some circuit and give some parameters and retrieve the values and then sonify them. The guys in Italy, they presented this work at Festival della Tecnologia in November, and I wasn't there, but I was able to give them a new version of the patch with the Max for Life device in a Max patch so that they could play it, and it was quite a success. People seem to like it. And the other project that I was involved with at CERN was an interactive story that we called Wolfiverse. This is Junior, which is also an Qiskit advocate. So this Wolfiverse project, it basically has like 3 storylines: 3 little pigs, Peter and the Wolf, and Little Red Riding Hood. And depending on your choices, you might end up in a different storyline and collect some items that will allow you to progress through the main story, which is Peter and the Wolf. And in these stories, you play the wolf, which is present in all of these stories. And it's a very fun project. But what I wanted to talk to you about today, and given my different background, is about computer music. And more specifically about CAC, which stands for Computer Aided Composition. If you heard about CAD, Computer Aided Design, you might understand what it means. And hopefully, by the end of this presentation, you'll be as excited as me about this new future QAC, the Qiskit Aided Composition or Qiskit Aided Design, or simply put, quantum-aided composition. So computer music, there's basically two ways in how people do computer music. They either use DAWs, which stands for Digital Audio Workstation, which are basically software suites for music production, or they do CAC, computer-aided composition, which mostly involves programming. And a DAW, if you don't know what it is, what it looks like, it's something like this. You have these layers, which are tracks. They play simultaneously. Time flows from left to right. Here at the bottom, we have a chain of devices. These could be effects that change the sound on each track or on all tracks at the same time. There are different ways to interact with DAWs, or different environments. This is another one with clips. You just select which clip to launch, and then you can edit the contents of each clip individually. But if you want to do quote-unquote serious computer music, you have to use computer-aided composition. And to talk about that, it's important to mention IRCAM, the Institut de Recherche et Coordination Acoustique Musique in France. They were very important during the 80s and the 90s. And this is a place where Max originated. And Max is a visual programming language originally for musicians, but now it's evolved so much that it's also used by visual artists and media artists and whatnot. And an interesting fact about Max is that it's named Max after Max Matthews, who was a researcher at Bell Labs. And he was the father of computer music programming. He basically invented the first ever computer music programming language called Music in 1957. And at the time, he built that for the IBM 704 machine. It has several different iterations. It developed the music computer programming language over the years. I think the last one that he worked on was Music 5. And it's a text-based programming language. And people don't really use it anymore because it's a little bit cumbersome. So it looks something like this. You basically are just defining parameters for this endless list of parameters. And it's very little intuitive. So Max, as a visual programming language, kind of sets a new way to think about programming. And what does it look like? It's basically, it has objects, you connect it with patch cords, and then you click these objects and stuff happens. Max was developed, it started being developed at IRCAM in '85 by Miller Tuckett, and he invited David Ciccarelli, but they departed ways at some point when Max became a commercial product in '90, and later in mid-'90s, Miller Tuckett released an open source similar version of the software called PD. But Max kind of took over as the lingua franca of computer music, and that is for two main reasons. Number one, it is extremely well documented, and it has interactive tutorials, and we have to thank this guy, Chris Dobrian, which happens to be my professor here at UCI, for that, because he wrote those interactive documentation. And he has several different recipes for almost anything that you can imagine. In fact, quite recently, he released this website called the Max Cookbook, which has hundreds and hundreds and hundreds of examples. And I know this because he hired me to work on it. And so extremely well documented. And another reason why Max is also the standard is because they were clever enough to integrate Max with other software packages like Ableton Live, which is a DAW. In this case, we can use Max just to create some of those devices effects that sit on the effects chain in Live, and they can also control other parameters in Live. So the difference between DAW and QAC sometimes can be a little bit blurry, and that is okay. But you don't. Sometimes there's stuff that you want to do with computer music that it's not just creating an effect. So, for instance, this it's the project of another professor of mine and my advisor right now, Michael Dessen, somewhere in the upstream from 2016. He had like this algorithmic composition and some networked scores, and he needed to create a very specific software. He used Max for this, and these are new ideas that extend far beyond what is considered the mainstream music. He also coined the term score streams a little bit more than 10 years ago, which stands for this. Let me see how I'm doing in time. Okay. So I also more recently started working with network music using Node.js when I started using it in 2016, late 2016, before I came here. And I started building my own web servers and making UDP connections between Max and Node. And this eventually led me to create pieces for 7 instruments, like BUD Sophia, for 7 instruments, plus browser-enabled devices and 1 conductor. And in the interest of time, I won't show this video, but I'll just mention that doing this work was extremely hard because I needed to compile, in order to share my work with other people, I needed to compile it in different systems. So I needed to grab my code and then run to the lab, to go to the Mac on the lab, and then compile it for the Mac, and then go back and forth and try to fix different things for different operating systems. Things got a little bit easier more recently when Cycling 74 released Node for Max in late 2018. And this allowed me to make a more easy implementation of score streams, which is this Ableton device that you just drag and drop, and it creates everything automatically. The web server and manages the connections and everything, because it has all my Node code embedded into it. This also allowed me to, having Node in Max also allowed me to experiment with Qiskit.js, which mostly I was trying to find my way through it and asking for help on GitHub and finding bugs. It is an experimental implementation of Qiskit, but eventually it allowed me to build some proof of concept devices that would have Qiskit embedded into it. These are drag and drop devices. In this case, this is a 2-qubit circuit, and you can load QASM from files or from the clipboards or from the MIDI clip. The MIDI clip, it will read what is the text on each MIDI clip and construct the circuit based on that. And here it's basically just saying what are the different counts or probabilities, and then mapping that into these remote gates that would turn on or off the gates for those particular instruments. But going back to score streams for a second, I actually presented it at IRCAM, in the IRCAM Forum workshops in last March. And David Ziccarelli was there. And I talked to him for a couple of minutes, and I said, he saw my presentation on score streams where I used Node for Max, and I was saying that it was a great addition that allowed me to do all this crazy stuff. And I told him that I was working on quantum computing and music composition and working with Qiskit and trying to implement it, and that the main library, that the Qiskit.js only allowed me to use a simulator, but I wanted to access the real machines, and the main library is in Python, so would there be a Python for Max? And he said, oh yeah, that sounds very cool. But you know, to bring that up and then having to support it, it's just too much trouble. So no, I'm not gonna ask anyone to do that. But you'll be able to maybe able to find a bridge between Python and Node. Needless to say, I was not very successful at that. And in the meantime, the Qiskit.js repository has been officially discontinued, so things are even worse. So in the meantime, I've been learning C++ this quarter, and that is because I wanted to build my own audio plugins and be able to create devices that would not just work inside Ableton Live, but would work across any DAW. And I've also started wondering at some point if I could work with, if there would be a C++ implementation of Qiskit. And I thought that Junior used C++, and I asked him, but he said, no, I work with C# and Qiskit. And you know, it's a great idea to have like a different implementation of Qiskit on a different language, but it's very complicated to do it. It's very hard to do it. So what about you doing something more simple? What about micro Qiskit? So then there was like this new hope that appeared, and me and Junior, we decided to go to Master Skywalker, that is James Wooten Skywalker, and ask him about micro Qiskit. And it's not only a new hope, it's like the last Jedi, actually, because in a couple of days, he was able to do a porting of micro Qiskit to C++. It's not complete. There's some work to do, but it was very important, and I'm really thankful for this support, and it has allowed me to start experiments this week with building a C++ compiled Max MSP object, which I can show you on my live demo section of this presentation. So the good thing about this is that you can just open a patch and then start typing the name of the object, which is microQuizKit CM, and then it says it has two arguments, number of qubits and the number of bits. If I only give the number of qubits, it's clever enough to understand that if I add measure gates, it will need to create bits. I need to send an initialize message, and the console will say, okay, circuit initialize, and then I start building my circuit using the message gate followed by the gate that I want to actually implement. So let's say gate H on H0, so it says added H gate on qubit 0 to circuit. That sounds nice. CX01, you can add CX gate on qubits 0 and 1 to circuit, and then let's add the measurements. So because I'm lazy, I'm just gonna do a placeholder and do it like this. So 0, 0, 1, 1, and then finally to run it, I will click send the message simulate, not here, to the object, and it will say this circuit could be expressed in Qiskit as yada yada yada, and the counts are that. And it sends this message out of the outlet as a list of the bit string and the counts. So this could be connected to a bunch of sliders, for instance. So let's quickly do that again. Here, 0, 1 simulates, and so it populated these sliders with the counts 522 and 502. If I had more qubits, I would probably need more sliders to store the values. So let's say 3 and initialize this guy 0, 1, 2, measurements 0, 1, 2, and simulate this guy. So it populated all these sliders with all the values from the counts. So the good thing about this is that, again, I just created a patch and started this object. And there's no, I didn't need to like open the terminal and start Python and start the code and then establish a UDP connection. Everything is built into this. So the great thing about this is that it's a single external object that is 1.6 megabytes, and it's easy to use, and it sits inside of this visual programming language that can be used to create whatever you want. And I started realizing something, that this is like an important thing, to make things that are easy to use. And to go back to my quantum synthesizer project, I had like this Max interface, I had like the Python backhand, and it needed to connect. It's hard to set it going, to have it going. Same thing with the Wolfieverse. There's like the Twine interface, but it also needs the Flask server, and they need to be connected and running. I also noticed this in other people's projects. Somewhat recently, I talked to Michel Grossi, who shared his Quantum Suite project, which is an educational tool, and it has like this web interface, but it also needs to be connected to some server somewhere in the cloud. So there's I see a trend here, which is we need some lightweight integration, something that is easy to use. And if we want for it to be able to do some more interesting things, like connect to the real machines, it needs to have a server somewhere in the cloud. And to talk about quantum computing in the cloud, what better example but IBM QX, right? And I mean, we can use IBM QX to do everything. So it would be great to just have more access to it directly using a different programming environment. So this is where I'm at. I'm sitting between these Jedi Masters and these droids, and I'm trying to figure out what is the best way to to make this work more seamless. And these are my call to actions to the rest of the community, maybe to have people push for a better micro Qiskit with connection to IBM QX, or maybe a simple API for IBM QX web interface in C++ or JS. Yeah, this is what I wanted to tell you, and this is my presentation. So I'm open for questions and your feedback. I hope you enjoyed this presentation.
Omar, this is James Weaver. Can you hear me?
Hi. Yes. Hi, James. Yes.
Wow, fantastic work.
Thank you.
I applaud you. So I wonder if one of the things you showed was Max with micro Qiskit plugin. I wondered if you could share a link to that. I assume that it's open source.
I just created it this week, so I can put it out there, but it's very limited right now. Yes.
Okay.
I can share it if you yeah, I'll message you the object so you can try it. If you're on Windows, I'll need to to compile it or change a few things.
Okay, or maybe a GitHub link or something. Whatever.
Yeah.
Okay. Thank you.
Thank you. And by the way, I really enjoyed your GitHub project on the quantum piano.
Oh, thank you.
Yeah, this was really great. I think you see this question in the Slack, but somebody asked, I think Jack asked about using Go. Did you consider that language, or you said you would focus on C++, and just curious if you considered Go.
I've never tried Go. I just started learning C++ this quarter because it's what allows me to build audio plugins and build MaxMSP objects. I don't know if it's easy to do these things with Go. I've never used it, but I'm open to it.
I have a question, and this may have been mentioned already, but is there a link so that we can start playing with this, or is it currently local hosted?
Currently, it's only sitting on my computer, but I can put a link online.
That would be awesome. Thanks.
Thank you. Thank you for your interest.
Yeah, if you need help, we can also. This might be a good fit for like the experiments page, if later down the road once you have something that you're comfortable with. But a link from GitHub would be great. Any other questions?
Thank you, Jack.
Sounds good.
Thank
you very much, Omar.
if I may ask, are many other people among the Qiskit advocates working with micro Qiskit or interested in having this kind of interface, simplified interface that would still allow to connect to the real machines? This is my main concern right now, because there's multiple ways to go about simulating, but to connect to the real machines, it's either like the fully fledged like Qiskit in Python, or it's extremely hard to just like adapt it to another language.
Hey Omar, this is Robert. So recently I was working with another quantum ambassador. We're loading we did a workshop where we loaded the Qiskit onto a Raspberry Pi. Um, so when you mentioned micro Qiskit, I started thinking in that aspect because it's kind of difficult to load the whole thing. So maybe looking for like just what you're doing there, maybe a subset to build it, and maybe come up with some kind of smaller, easier way for either people or students or workshops and these such that use Raspberry Pi to kind of figure out a nice way to integrate that with this kind of a UI you have going on. That might be maybe an interesting idea to look into. Just a suggestion.
So do you have a link for that project? I think we need to talk after this call because I'm interested in that.
Yeah, sure. There's I'll find out where he has it on his GitHub repo, but I think it's public, so I'll get it to you. No worries.
This is Jack. I've been kind of interested in some kind of higher level abstraction interface that isn't in its syntax implicitly tied to the notion that the quantum device is something you have to dispatch jobs to remotely, something that could survive beyond the time when the quantum device is a web application and be equally effective at a time when the quantum device is more tightly coupled with the classical execution platform. It may be a premature kind of thought at this time, but I'm very impressed by all these efforts to provide more and more convenient integration to a simple quantum computation independently of how that quantum computation is dispatched as a job.
Hi, Jack. Thank you for that insight. I agree with you, and I feel the same. And in fact, I think that's what I'm trying to do is to create a higher level of abstraction of all this quantum computation process, not only to make my life easier, so I won't have to do everything every single time, but also to be able to talk to others and have others involved. Because I realize that asking my peers here to start a Python server and then start Max and then change the correct ports so they could talk properly, it's just too much of a hassle, and then people will give up. So part of my work is being trying to streamline the process of having to set up these new tools and to make them more easy and fun to interact with, and hopefully people will be more interested in using it. So definitely pushing through having a high level of abstraction of things will, I think, make it easier and draw more people in.
Hi, it's Luke Skywalker here.
Hi, Master Skywalker.
So in MicroKiskit, I think I implemented the thing where, or at least the C++ version, where you can ask it to give you the Python that you would have needed if you had done it in Python. To have it, at least you could do it manually, copy and paste. But that's maybe some way that we could look into trying to make this a bit more streamlined, in that we could maybe have it as part of IQX that you can give the Python as a string and then have it execute like that. I don't think that's how it's done at the moment. Maybe we could see if there's any roadblocks into doing that.
Thank you, and I'm looking forward to continue interacting with you in this regard.
Yep, you too. Sounds great.
Is Micro Qiskit, is that project public or available?
Yeah, it's on my GitHub at the moment.
Okay.
Quantum Gym Micro Qiskit.
Okay. Cool.
Yep.
Yeah.
Yeah, Laurent, it's a good question though. So moving forward, if we have these little projects we got going on, do you have a process that you want us to kind of share on the community, or just create something and create an issue and put stuff in there? How do you?
Yeah, I mean, I don't think there's a set process right now. We have a community repo that obviously you can contribute to, but it's kind of a mess. And so having it in your repo, I feel like is a good way of just keeping it kind of clean and maintained. And then when it's ready to be potentially contributed to the main repository, then we can look at something like that. But
Okay,
I think
didn't know if you were thinking about doing advocate, just get advocate repo. With those things,
yeah, I mean, we totally could have something like that if that is of interest.
Yeah, only because I started thinking for some of these projects that I'm seeing, they're pretty interesting, right? I see some of the stuff that both James have been working on, and things are really nice to kind of put like in a Qiskit advocate repo toolbox we can grab, and if I'm doing a workshop, it'd be good to grab one of those.
Yeah, I mean, there's the experiments page that is being built to kind of highlight some cool projects, but they're less like you mentioned, like a toolbox. It's more of a kind of applications based showcase. But yeah, I think that would be a good idea to have somewhere that we could aggregate them. I can look at getting an advocates at least folder created potentially.
That's a good idea too.
Yeah. And then we could have a README with just links out to various tools created by advocates.
Yeah.
Great. So I'll have this posted up today. Thank you very much, Omar. This was definitely a really interesting project.
Thank you.
And your background brings
since this is going
flavor to it.
Since this is going for YouTube, don't forget to like, subscribe. I'm joking.
Yeah.
All right.
Sounds good.
See you guys later.
Thanks, everyone.
Well.
Bye.
Bye.